Alright, so now I'm going to show you one past year question. This one, if I'm not wrong, is SPM 2013. I just snapped from the past year books. Okay. Is interesting questions. SPM 2013. Here you are, this question. Try to solve. SPM 2013. So please share your answer in the chat room. It seems like today we can finish this chapter. Because the next one, the nuclear energy, no much thing we can practice because the substitution formula and get to know the process is what is the process, that's all. Alright, so I think within half an hour we can done already. Okay, please solve this question first and share your answer in chat room. Why no one share the answer? Come on, please share your answer. Alright, girls. Come on, anyone, please share your answer. Hello. Okay, got one answer A. How about the others? Is it all agree with answer A? Engineering answer D. Any others? Then the other go B or A D. A. So only two options, A or either D. Okay, I told you what, these questions got no answer. Even when you refer to a past year book, they given the answer is A. So actually until today, there are still many teachers take this question to recycle, use it in the school internal exam, right? Especially during the trial, but they didn't notice that this question actually is wrong, right? This question designed wrongly. Actually, the question is no wrong lah. Only the options of the answer given, there's no correct answer, right? Because the expecting answer given here, right, or the suggested answer given here is based on the wrong concept of half right. That's why I told you from the beginning. You, for the half right questions, you only able to know the time taken when the sample declared 50%, declared half of its previous initial mass. If not 50%, then you cannot just simply predict based on the linear ratio. Cannot. I repeat again. If there is no complete one half right, which is decreased half, the time taken, you cannot just based on the linear ratio to do the calculation. What it means here is like this example. Let's say a sample is take 1 day. A sample take 1 day, 24 hours to decrease 50% or to decay 50% and remaining 50%. So 1 kg become half kg. It take 1 day. You cannot say half day, then it will be remaining 3/4. Because you cannot say because teacher 1 day it will decrease half. 1/2 gone. Then if half day, then only just 1/4 gone lah. You cannot do this prediction. If you do these predictions, means that your calculation is based on the linear calculation ratio. Then you got not apply the decay curve concept. There is no half right. It's wrong. So we only learn half right is it will be take constant 1 day, okay, minus half. So original 2 kg, after 1 day, it will remain 1 kg. Another half day, 1 kg, it will minus half, remaining 0.5. Another half day, another 1 day, the 0.5, it will decay another half, so will remaining 0.25. This is only we know. But you cannot say, okay, 1.5 day, so 1.5 day will be the 75% gone because 1 day take 50% gone. So another half day will take another 25% gone. So only remain 25%. So the concept is wrong. If like that, at the end, it will finish become 0. If you follow the half right concept, it never becomes 0 because it always minus half, always minus half, always minus half. It never becomes 0. Just like you cut the cake. You always cut half, 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 half. At the end, it's still remaining half. No matter how small, but it's still remaining half because always minus half with the same constant time. So based on the correct concept, this question, no answer. This question will answer because of the wrong concept. Why? Okay. For those answer D means that you don't understand the questions. All right. So this question told you that 25% of the sample has decayed. Decayed means that it's the one gone, minus. So it means that original, you have 100%. The question told you after 15 minutes, after 15 minutes is gone, minus 25%. Decayed. So how much you demand? How much you have after 15 minutes? After 15 minutes, you have 75%. So now the question asking about what is a half-life. Half-life means that we want to know 100% become left 50%, means that you're going to decay 50% to remain another 50%. So the question want to know what is a half-life to decay 50%. So it means they're going to gone minus half. So for those answer A, you thought, okay, so 15 minutes minus 25. So another 15 minutes will minus another 25. So minus another 25. Then it will remain 50%. So this is the 100 to become 50. So how long it take? 30 minutes. So 30 minutes will be the half-life. So that is the original idea of this question. That's why it gives the answer is 20 minutes. But this answer is wrong. Because there's a wrong concept of half-life. If you think so, means that later another 15 minutes, what happened? Another 15 minutes, it minus another 25%. So become 25 here. So another 15 minutes, so minus another 25, so left 0, no more. So it means that after 2 half-life, then 100 becomes 0. This is the wrong concept. But right, because after 2 half-life, it will be 1 half-life 50, left 50. Another half-life, it will left 25. Because it will minus half. So another half-life, it minus half, 12.5. Another half-life, 6.25. Another half-life, 3.125. Another half-life, 1.7. Is it? 21. 1.7125. So, is it 1.7125? 1.7025. 0.25. Something like that. Okay. So, always minus half, minus half. So, when always minus half, it never becomes 0. That is correct concept of half-life. So, if you apply this wrong concept of half-life, you will get 30 minutes. The answer is wrong. No, because of the decay is spontaneous. Okay. Decay, yes, decay is spontaneous. Spontaneous here, okay, so later I will explain what's meaning by the spontaneous. Okay. So now you have to understand about the half-life first. Half-life, always remember, half-life is during the constant period of time, the sample, it will be half decayed, gone, reduce the mass. Half mass will be reduced, will remaining half in the constant time. After another same constant time, the remaining what you have, it will be gone another half. So it will remaining another half. Right? So it always gone. It's just like if you imagine that you makan cake, potong cake. Okay, potong cake. So now one complete pieces of cake. Okay. After 1 hour, okay. So half cake gone. So we remaining another half. Another hours, another half gone. So we remaining 1/4. This 1/4, another hours, half will be gone. Another hours, half remaining will be gone. Another hours, half will be gone. Another hours, half will be gone. So it always half gone. So it means it never becomes 0. Only becomes smaller and smaller. But it never becomes 0. At the end, it becomes the dust. When it becomes the dust, it's still taking the same constant period of time, decrease half and remain half. Right? So then this case, how are you going to solve it? Then our only choice is we use the formula. Okay. So you have to be careful when we solve the question because of what? Because you have to be careful the terms here. The terms given here is what? 25%, 25% decayed. 25% decay. So it means that how many percent demand? 75% demand. So means that the end we have after 15 minutes, and we have is 75%. So what is the original? Original will be 100%. So after the time t, 15 minutes, so after the t equal to 15 minutes, then the number of nuclei demand is 75% because the question told you 25% decay. So you only demand and 75%. So now the question looking for half-life. The question looking for half-life. So we substitute the equation. You got 75% equal to 1 over 2 power for n and multiply 100%. Apply the formula. So now with this formula, try find out what is the actual half-life. What is the actual half-life for this question? Do the calculation now.阿明家做功课，你做了没有？快点做，不然等下马云上完课你也是中了。Anyone got the answer already? How much half-life if you use the formula? Please share your answer, please. So your answer should be 36.14 minutes. Right? At the end, I still have the answer for you. 36.14 minutes. Okay? So there's a way we solve this question. But we do able to solve it if this one is a 2013. 2013 in syllabus, we didn't introduce. We didn't introduce about the formula. Then how the student able to solve this question? Okay, if they say this, let's say there is a question that is incomplete half-life like that, like the question they want is how many half-life? The half-life actually is how much? The half-life actually 0.415. 0.1415, not even half-life. All right, so 0.415 half-life. So how are we going to solve? Actually, we can use a decay curve. We can use decay curve. We can use decay curve to help to predict the answer. Okay, so we show the one decay curve. All right, example, use a decay curve here. This one's an n. Okay, here n over 2. This one n over 4. This one's n over n. So we show the interval time, constant interval time. Okay, here. So we draw a decay curve. Okay, so now we try to enlarge it. Okay, so based on this decay curve, so our minus 25% and remaining 75%. So it means that it minus 1 over 4, remaining 3 over 4. So remaining 3 over 4, where is it? So 3 over 4 will be here. Okay, this one's a n multiply 3 over 4. Yeah. Okay. So it means that you based on this one, okay, you get the time here. You get the time here. Okay. So now from here you see, okay, this one is 50 minutes. So now what we know is we want to know is about this half-life. So based on your graph, let's say this one the length here, let's say it's 2 centimeter. This one definitely will be less than 1 centimeter. Let's say this one is about 0.8 centimeter. So now based on this time, you can use the ratio to count. Okay, you can use the ratio to count because you want to know that 15 minutes over 0.8 then multiply 2 centimeter. Right. So based on that, you can calculate, okay, and get to know the answer. Just an example only. 15 divided by 0.8 multiply 2. So 37.5 minutes. Then the half-life will 37.5 minutes. So this one just roughly I show you. Right. So but actually this one it should be less than 0.8, about 0.7 something. Okay. So based on the ratio, we're able to know about time because the time is a phase. Ratio of time is a phase. Only the decay will be based on the curve. Decay curve. It's not a straight line, it's a decay curve. So that's why when the three-quarter demand is not remaining three-quarter here. No. It's not taken 1/4 and remaining 3/4. It's not like that. Because it's a curve line relationship. All right, so we still can use the decay curve to predict the answer, but the answer is not accurate. To get a more accurate answer, we should apply the formula. All right, so there's an example about this half-life problems happen in the past year SPM. So hopefully that you notice about that.